Hmm. 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 Hey, what's up, folks? So I think it's about time we get back to some of these old projects that have been kind of sitting on the shelf collecting dust. For those of you who haven't seen the older videos of the telescopic taper attachment, this is the telescopic lead screw that I made for my Atlas lathe. And thanks to a fellow YouTuber, Everett over at Everett's workshop, he built me this beautiful, super long dovetail. Well, you see it, well, it didn't come with the marker. So back when I started this project, I did not have a milling machine. All I had was a milling attachment, and there was no way I was going to be able to tackle a project this size with any amount of accuracy. It was my design, but Everett made it out of a very well thought out CAD drawing of mine. Not so well thought out, I should say. There's been a couple of addendums. This is the 2.0. Now it should work technically as is. Like I don't expect to have it this long. I'm going to be cutting it off right about there. But my biggest dilemma right now is, but weighing this thing out, it's kind of balancing there. So we're almost at 22 pounds, and the weight of my whole carriage is about 25 pounds. So with all that extra metal, I am not really sure. I don't think that's such a good idea to put that much weight on that little dinky carriage of mine. So I'm going to have to do take some drastic measures to lighten this unit up a little bit. So what I'm going to start off doing, I'm going to cut that off there. Probably going to shorten this up a little bit too, I think. All right, according to this, we've shaved nearly about 3.5 pounds off there. So that's a start. All right, so we got a 1/2 inch solid carbide end mill in there at 950 RPM. We're gonna side mill this. We got about 85 thou to take off, so just until it's nice and square. We're right at the very edge of my travel here, so we're just gonna touch off here. It's the low spot, I think, or the high spot. Just so we're not taking off too much by the time we get to the end. Well, in about 25,000, see how that goes. Really? Alright, it's about 12,000 good. Okay, one more quick check here, just to make double sure. It's not a make or break dimension, but according to that, we're looking at about 6 thousandths. Yeah, that looks pretty good, I think. All right, so in order to establish exactly where I'm going with this thing, I had to just give these a quick fly cut. There was, given my lathes got some bed wear, so it tends to give a little bit of a dishing effect in there. And there was some light in that I could see through in the bottom here. I don't know if I can show you. I don't really have a flashlight with me. But anyways, that joint in there, I got all the light out of it, which was the important part. and also to make sure that this and that was actually, and this was all perfectly square. So I'm quite happy with that right now. What I gotta do now is we're gonna set this up in the mill, and we're gonna find our center point, and we're gonna mark some spots for holes. And I can't really go any further. I'm not really sure if I do 1 or 2 or 3 bolts. I don't know. I'm probably gonna mill out some pockets down here, just to, you know, some metal reduction, I guess, to lighten it up. I'd like to get it down to about 10 pounds if possible. So I'm gonna set this up in the mill. I'm gonna start drilling and tapping some holes here. All right, guys, so I've got it set 1.5 inches from dead center. I'm gonna do the same on this side. At some point I'm gonna have some locating pins, but probably won't do that until I get the other piece mounted on there. For now, let's get this drilled out and ready for a 3/8 tap. Go. Might have been a little fast. I'm not going to do this under power. I'm just going to get it started here. And since it's kind of a blind hole, I'm going to run through there with a bottoming tap just to make sure we got enough threads. Or semi-bottoming. Alright, that should be good. Alright, so I'll do one more over here. Get right back to you. And this side is done. Yeah, it's done. Alright guys, so this is going to get a through drill and counterbore. I knocked out the back parallel just to spare it from getting potentially damaged. Well, the RPMs are a little high. Before I go and change them, I'm just gonna do this other. I'm gonna pilot this other hole first. It's the beauty of having a DRO, I tell you. It's freaking godsend. Almost feels like cheating. All right, so this is about maybe the second time I've used this. So what I'm gonna do is I'm just gonna keep pecking away at it. It should be about 3/8 of an inch in depth. And I hope that's slow enough. We'll see, I guess. Lots of oil on it, just to be safe. Seems a little fast. Very smoky. That looks like. Nope, still a bit more to go. That's probably okay right there. Stick out just a wee bit. Yeah, I'm gonna leave it right about there. I don't want to take out too much of that meat. So I'm gonna lock it up here on the quill. Just kind of use the quill stop. One of those features I rarely use, to be honest. Okay. This piece is ready to test fit. Alright guys, I believe we're all here. Got our parts all drilled out here, and we're going to do a quick test fit up here just to make sure all the holes line up. I'm fairly certain they do. Oh yeah, so far so good. So this is the back side of it, which will have some allowance for Gibbs screws at some point. But what I really want to do after this is set it up on the lathe and see just how heavy it is. If we're gonna have to mill out a bunch of material to lighten it up, or if it'll be just fine. We'll see. So we're gonna have to drill these in a minute to accommodate some locating pins, because these holes are not drilled out for locating purposes. They're just for fastening purposes only. Lots of machines are like that. You see they'll all have either tapered dowel pins or just some normal dowel pins. But that is looking pretty good. Let's go mount all this stuff on the carriage and see what it feels like. Alright, well I got it all mounted up there. Now I'll be the first to admit that this dovetail is completely useless. I don't know why I did that. Apart from locating purposes, it's pretty useless. It might actually end up being a problem. But I do need something here for stability when I get the bar running through here. Anyways, let's get the rest of the parts. Well, I shouldn't say the rest, but the majority of the parts. Get some of these oil cans out of the road. Okay. Dovetail. And angle, ideally. Wow, actually that doesn't feel any different at all. Oh, that's gonna be awesome. So now you guys see how that's how a telescopic taper attachment works. The lead screw is firmly attached through here, and then as this slides, it will trace the taper out. Yeah, that does not feel any different at all. So maybe we don't have to hog anything out. That's good. I do believe at some point though I'm gonna have to thin this up a little bit, and I'm thinking I may actually cut another dovetail in this. I'm just kind of playing by ear, so bear with me here. All right, so a little bit of a quandary here. I'm just doing a kind of a makeshift mock-up to see where the lead screw is going to end up being. Now on top of this, there's going to be another block, to which this is not this piece exactly, but something very similar is going to be on here, and it's going to have to be able to swivel on there as well. But as we're looking at it right now, I only got about 1/8 of an inch under here to actually have room for the block that's going to slide up back and forth on this. I got the other piece of this in the mill, thinking about doing another dovetail. However, I'm not really entirely certain if I'm going to need that, because this is already very dimensionally, good, because it's all precision ground. Well, I'm also not sure how well my dovetail cutters are going to handle this 01 tool steel. All right, so I've never milled this stuff before, so well, have I? I don't know. Not really. I haven't milled tool steel, not to my knowledge. Nothing this drastic anyway. Just gonna true up the sides here. Something incredibly stupid. I went backwards. I don't know if that. Oh my god. Well, it's still cutting it somehow. Okay, I'm gonna reset my X. I want to get this as close to 10.5 inches as possible. I'm just gonna shut that off to avoid any more embarrassment. I'm just using the DRO to get a mostly accurate read on here. Oh yeah, I buggered that end mill up good. There we go. Well, I am not entirely certain how well this is going to mill out. We're going to start by taking a 1/4 inch off each side. Let's see what that looks like. Almost 100 thou, I guess, for depth. Well, that was in fact a little bit on the scary side. The chips were definitely a little on the hot side. Seemed to make a pretty nice cut though. Yeah, that ain't so bad. A little bit. It's roughing. We're roughing it out right now anyway, so. That was pretty crazy. It's kind of getting hot at the end there. It's looking like it was making some sparks just about, so you might have to Well, that's all we're doing for the big meaty passes anyway. Another 50 thou depth. There we go. Bust my end mill. It's possible. Kind of sounded like it. No, I can't see nothing. It was just a chip got caught. Okay, well I hope I got this thing focused on the right unit here. Camera's gonna clear. Okay. Oh, it's the fun bit right here. So we got it about 420 RPM. I'm not sure if that's gonna be faster. Too fast or too slow. We're gonna need some cutting oil for this one. Touched off here first. There's something rattling on my machine. Essentially a new sound. I don't like it. Here's our touch off. Reset our Z-axis right there. Reset our Y right there. Got it saved in absolute, so we can always go right back to our 0. I'm hoping this isn't too fast. We'll go in probably about 50 thou right off the bat. Well, this is going to take quite a few more passes yet. Actually, yeah, we got a ways to go yet, but this part's getting pretty toasty. I'm going to let it cool off. Just I don't want it to warp or do anything weird. It's not supposed to be able to do that because it's supposed to be all stress relieved and stable and all that stuff. So, but I'm still going to give it a few minutes to cool off. I'm going to get back to you when we're just about done. Alright, well for the most part, just need some deburring. I think that's, well, it's not done. So there's going to have to be a fairly large, like a shoulder bolt right smack dab in the middle of this, so that this can swivel on top of the other dovetail. So I wanted to keep this as wide as possible without, you know, making it too wide and then not having enough meat for the other piece to grab. I'm going to clean that up and see if we can't get some measurements off of it, just to make sure there's no pesky taper or anything weird that's not going to work out for us. That did actually produce a very nice finish on that. That tool steel milled up pretty nice. I cannot complain at all. Well, I don't have much for gauge pins or anything like that, but I do got some carbide end mills that should do the trick. I may actually, no, that should be the right size for a 2-inch mic. Camera shaking. And 1 inch 9, 13 and a half. Yeah, I'll try this end. Holy cow, that is dead nuts on. I don't know if you can see that. Oh, try focus. It's not going to focus, is it? There we go. Dead nuts. I'm going to call that good. Alright, so since our dimensions or our center was saved in our absolute function, we just switched it back to absolute and found our center dead nuts on. So what I got to do here, I'd like to bore a 3/4 inch hole. Like it's going to be a shoulder bolt's going to be going in there, and it needs to sit flush. So, and it's going to have to be pretty rigid, pretty strong, and very well fit. So I'm probably going to end up busting out the boring head for this. Start it off though. I'm going to just drill this out. Alrighty. Wow, that is spectacular, that finish. Oh my God. That is the nicest bore I've ever done. According to this, we got 4 more thousandths to go. I'm gonna try to put this lined up and get a slightly more accurate read out of it. So we just want to write 2 thou out. I don't know how good you can see that. Probably not great, but. Okay, I'm going to truth. That is, oh, that's beautiful in there. Really nice. Oh, I'm like 2 thou over. No, 3 thou over. That's okay. We'll make it do. We'll make do. That's why we did the bore first. It's a lot easier to turn the bolt or whatever than it is to nail it on the bore. I'm gonna have to put some kind of a shoulder in there. All right, now for the head of the bolt or whatever, I'm gonna have to put a little recess in there so it can lay flush with the top of this. All right, so this is gonna be my attempt at making a shoulder with this boring head. I don't know how good it's gonna work. Get the touch off. Okay. Now I'm just gonna set the depth stop now, about 1/8 of an inch down. Well, eyeball, it doesn't have to be exactly 1/8. We get it pretty close. In fact, we can actually even use a parallel. These gauge in at 1/8 of an inch, so in theory, put the stop up here with a 1/8 spacer. It should stop us from going too deep. So we're gonna have to do this in increments. Fine enough so that it doesn't just leave a bunch of mess on the bottom. So that's the plan. Really gotta do something about all the rattling on this damn thing. It's terrible. This works. Doing these in about 20 thou increments, or 10 on the, so I think it's 10. I'm hoping I don't have to go any finer than that. We'll see. Yeah, guys, this is gonna take forever, just so you know. I'm gonna bring that hole out, or that shelf, about out to 1 inch in diameter, so got a ways to go. All right, last pass. It's actually looking pretty good. Nice. I was full on expecting that to start chattering. Oh, I wish I had a chamfer thing for this. I don't have one though, so I guess we'll just have to do it the old-fashioned way. But for all intents and purposes, I believe this part is done for now. Well, all right, guys. There's our part that we just milled up. The bore, as well as the shoulder, turned out really good. For some weird reason, they are both exactly 4 thou oversized from what I was shooting at. So, I don't know. There's something with that. Maybe just springing the bar. Oh well. It'll come with practice. But yeah, like I haven't even really stoned these dovetails. And they turned out very, very clean. Very nice. Not bad for an AccuSize cutter. We'll stone these further. This has got a little 60-degree angle on it. And for now, that's about it for this part. I got some more logistics to go through. I'm hoping to find a nice milling head. We're gonna have to take about 1/8 of an inch, maybe 3/16 off the top of this, just to get a little more clearance in there. The dovetail definitely helps, because now we'll be able to have a bigger block over that. And plus, well, it'll keep it from popping off of there, give it a little more rigidity. But that's about all I got for tonight, folks. Until I get some dowels and hopefully another big cutter, I don't think I can go much further on this. I'm in full-on project mode now, guys, so stay tuned. We're gonna definitely have more on this coming as soon as possible. Thanks for watching. Peace out. It's a pretty expensive hunk of metal right there. I'm glad I didn't screw it up.